States of matter. Many of you have memorized states of matter. Sometimes it's also called phases of matter. Um, and you've memorized these probably somewhere. If you haven't memorized them, you've hung on to them. But usually we talk about solid, liquid, and gas. And the fourth state is plasma. We don't talk as much about plasma in general science classes, but we do want to address it here. So there are these four different states of matter. This is just a little bit of a mini lesson on these different states and the characteristics that they have. Now, there's lots of things around us that are solid. There's lots of things around us that are liquids. And there's lots of things around us that are gas. In fact, we're surrounded by the atmosphere that just surrounds us with air, and air is a vapor and gas. And then plasma, there are places around us that have plasma. If you have fluorescent bulbs, there's plasma taking place in fluorescent bulbs when you have fluorescent bulbs turned on. But there's lots of things that are happening there. We can start to describe these states based on the characteristics of the volume that these states have. Now, does that mean, I'm not saying that all solids have the same volume, that all liquids have the same volume, or gases have the same volume, but what I do want to get at here is that the volume of a solid has certain characteristics. And that characteristic is that the volume of a solid is definite. It's defined. It doesn't change based on pressure. It's fixed. It's definite or fixed. Now, okay, it's fixed to a certain degree, and there are extreme conditions that can change the volume of a solid. But for the most part, the volume is fixed, and it doesn't change based on atmospheric pressure and those types of things. Now, the volume of a liquid also is definite or defined. You can't compress a liquid. Its volume is fixed. Now, maybe I better contrast here what I mean by definite or fixed. If we talk about the shape, now, all of you, I could put this on a video for you, but you don't need me to put this on a video for you. If you take a glass of water, okay, when the water is in the glass, it has a certain shape. If you pour the glass of water out on the table, the shape changes. And so the shape of a liquid is free to change. It's indefinite. It's not fixed. Okay. How about a solid? If you think about a solid, the shape of a solid is defined, or it is definite. Okay, physically you can take a block of wood and cut it in half, and essentially you've changed the shape, but it doesn't change on its own. It's fixed. Okay, it's fixed. And then the gas, well, the volume of a gas is indefinite. It varies. You can compress a gas. If you have a container, you can use a pump to put more gas into that container. Think of an air compressor that we use to provide pressurized air to blow up tires or to fill tires with air, or think about your own lungs when you go to fill up a toy or a balloon. You're able to force more air into a space. Now, a balloon's a little bit different because the balloon expands, but the volume changes. And if you think about it, a gas, the shape of a gas is also indefinite. It changes. It's variable. In fact, sometimes that's the word that gets used, is by indefinite. They say, well, it's variable, which is very much the opposite of something being fixed. So here, where I've said just change that. Instead of saying it's, put this word variable in here, because that's really what we're saying, is it varies based on other conditions. So it's variable. Now you have to see the relationship here all has to do with the particles and the amount of freedom to move that the particles have. In a solid, there's little freedom of movement. There are going to be some, but for the most part, the particles of a solid are very tightly stuck together. So there's little freedom of movement here. In a liquid, the particles sort of slide past each other. They can move they can move around some, and depending on the liquid, there's different amounts here, but they can move some, but they're still stuck together. Their movement is limited. You know, if you take a glass of water and you pour it on the table, its shape changes as the water molecules spread out and move past each other. But the water doesn't take off and become part of the air very quickly. It takes a while for that to happen. In a gas, though, there is almost maybe I shouldn't use the word complete, but for the most part, there's this complete freedom of movement, as the particles are free to just zoom around and pretty much go where they please. Now, plasma is a whole different thing, and you know, of course, here in plasma, the particles are even more energized. Okay, actually, it's to the point where they're ionized, and oftentimes plasma is not included in part of this diagram because it's very different in so many ways. But you know, plasma is highly energized particles of matter. And probably, you know, this is a plasma ball, and some of you have seen these, some of you may even have these, but you can see there's light being given off, indicating that there's something happening there with energy and electricity to produce this state of plasma. In terms of volume, though, plasma is, you know, it's most closely related to the gas. It's really got a variable. It's the volume of a plasma state is based upon the pressure around it. Its shape is also variable. And by variable, I mean it's indefinite. It's not defined. Particle Freeman, you look at a plasma ball, lots of freedom of movement. So what makes it different than the gas state? What is different between the gas? I mean, what is it that causes something to go from being a gas to being in the plasma state? And the thing that happens here is a process called ionization. There's so much energy there that to get to this plasma phase, so much energy needs to be provided that the electrons, ionization is related to electrons, and we are going to unpack that in future lessons, but this ionization takes place to move from a gas to a plasma phase. So these are our states of matter. These are physical properties, and that's the last thing I'll just put in here in this little lesson, is that these things have to do with the physical properties, distinguishing physical from chemical, but these are physical properties of these states of matter.